Let's make some Payjoins. We're going to be using the Payjoin dev kit to receive version 2 Payjoins, which means the sender and the receiver are asynchronous. Payjoin dev kit is alpha, so the API might change, and we're going to show a simple example where we don't handle every single error. But follow along, and you will be able to set up the receiver with Bitcoin Core on Signet, and you'll see what it takes to receive a Payjoin. Let's get right into it. First things first, we're going to start a new cargo project. We've got Bitcoin Core running up top. On the left is my workspace where we're going to run this, and on the right, we're going to actually run the sender client at the end of the video. So first thing, cargo new, receive. We have a new package. We're going to open this new project. We need dependencies first. What are those dependencies? Bitcoin Core RPC is our wallet. Rust Payjoin, this is the Payjoin dev kit with receive version 2 and IO features. Receive lets us receive, v2 lets us use v2, and IO gives us a helper method that helps us bootstrap in our environment here. Request lets us make HTTP requests, which we'll need to actually communicate with the sender. In Payjoin v2, you communicate over oblivious HTTP to protect IP addresses, and a directory server that can store and forward the communications between the two as encrypted blobs. That way, the two can actually communicate and go offline. Someone else can run the server. We need Tokyo so that we have an async runtime just to make this tutorial easy, and URL so we can parse URLs. We're going to make this a Tokyo runtime and an async function, and we're going to return a result that's a box error, just so we can use the question mark operator for ease of use, and we'll return OK and the unit type. We're going to manually set our OHTTP relay and Payjoin directory so that they're the same every time, just for simplicity. So this is the Bob Space independent oblivious HTTP relay set up for Payjoin. We'll use that, and then we need the directory. We're going to use the one I run, the payjoin.org runs at payjoin. Payjoin. Good. Okay. And now we're actually going to fetch oblivious HTTP keys. Oblivious HTTP does encryption without TLS. It doesn't depend on TLS. So in some environments like Bitcoin Core, you might have keys shipped with a binary in the future, but we have TLS, fortunately, so we can use that as a bootstrap mechanism by fetching the keys using the HTTP connect method over a proxy, which is also the OHTTP relay. This is where the IO crate comes in. And this is an async function. And we can just ignore the error for the sake of the tutorial. Oh yeah, we need to import URL too. Nice, we should print this. Print the keys. I'm using Copilot++ and Cursor, by the way. It's fabulous in my opinion. I think it really helps speed up development. We can just see that this runs and it'll fetch the key. I don't know that we'll run this until the end of the tutorial from here on out, but it's good to see us start. There we go, we got the keys. So that proxied through the OHTTP relay to the Payjoin directory to get the oblivious HTTP keys that we can encrypt packets to. That way the relay can't see what we're trying to request, and the directory can't see the IP. Each only has one element of this that really protects us. So the next thing you're going to want to do here is set up a wallet in Bitcoin D. So I have this, if I list my wallets, I've got 2 wallets. I've got Receive and Bob. You're going to need to make sure that they both have funds. Which I do. In order for us to Payjoin. Beautiful. But we'll get back to that later. The important thing now is that we connect the Receive wallet up to our program in order to receive these funds. And we're going to do that using cookie authentication and RPC. So the RPC host for a wallet named Receive is going to be on Signet. I'm running Signet. It's going to be at 38332/wallet to be specific, and then Receive to be that specific wallet, and then we want the cookie. And we want to actually parse it as a cookie. So we're going to use the RPC library for this, which is Bitcoin Core RPC auth cookie file. I think that's right. And then we need an RPC client. So we have Bitcoin D is Bitcoin Core RPC client new using the Bitcoin D RPC endpoint and the Bitcoin D cookie. Not just a string, we need a path, right? Okay, so now we have this client we can get a address from, and we want to make a session here. Okay, so we want let address equals Bitcoin D. If you're familiar with RPC, this is the same syntax. So we don't need to label it. We don't need to specify a type. We're just going to use defaults. That's fine. And then this gives us enough. We have enough information now to actually create the session initializer. Session initializer new address. We're going to assume it's checked because we just got it from Bitcoin D. We know we're using Signet. What happened here? We need to import the RPC API. Okay, there we go. Assume checked. Has some more details that need to be filled out. It needs the Payjoin directory. It needs the OHTTP keys. It needs the OHTTP relay. It doesn't fetch automatically because, like I said, you could get the keys from the binary and you wouldn't need to make that fetch every time. And then it also needs a duration for how long our session is. Duration, we'll do 10 minutes. And we need to make sure we're cloning these because we're going to use them again. So the memory needs to be moved. Okay, we have this session initializer. Let's initialize the session. This pattern is going to come up again and again, where we get a request and an oblivious HTTP context, and we extract that request from the session, and then we actually make the request. So we're going to make an HTTP client. And make the post, and we have a few different requirements. So first, post the body, or sorry, post to the URL, post the body, make sure we have our content type header set to oblivious HTTP, which is conveniently in Payjoin. This is v2 request content type. Beautiful. We can then send and await it. So we got this response, and then we'll need to process the response. And to process the response, we need a read object. So we're going to get an active session. By processing the response. I don't think bytes are going to work. We actually need something that implements IO read, so that's going to be as string, nope, as slice, yeah, as slice, and it takes the context because each time you make a request, you need a new context. So in case that fails, you have a separate context there. That decapsulates the oblivious HTTP that the relay doesn't know the contents of, but we're able to decrypt. Okay, on to step 3 now. We have this session. Now we need to listen on a Bitcoin URI with Payjoin support. This is how we actually make an invoice, basically. This is a Bitcoin URI is a standard format that basically any Bitcoin wallet can read, and if that wallet supports Payjoin, it will automatically make a Payjoin attempt, and if not, it'll just send to the address, which is okay. Payjoin's backwards compatible like that. So we're going to get the URI from our session. We're going to set an amount. We'll do 88,888 sats. We should be able to build that, and that'll give us an actual URI that we can print. We don't, this is not fallible. Okay. We'll put this on a new line to make our lives easier. Good. Now we want to actually listen on that URI. So the session initialization, I should say, this request requested a store and forward box on the Payjoin directory. So the response to this contains a session identifier that we'll see when we print the Payjoin URI. That will be clear later. But now we're going to process a response by long polling, so we get this asynchronously. We're going to do that by looping and use that same pattern we did again. So this is let request context equals session extract request. Get that response. Oops. Post request URL. Get the body. Set the header. This is getting way ahead of us here. We just want content type. Okay. We send. We await. And we get that response. Okay, so now we process the response in a match because there's 3 different possibilities we could have. So when we process the response as before, in the context, so this could error. And if it errors, we don't want to deal with that. In production code, we of course would want to deal with that, but us right here, we don't want to deal with that. What's going on here? Oh, we just don't have the arms. Right. So if we get a proposal, this is the happy case, the happiest case, Then we will break and return that proposal and assign here. If we don't, we can just continue to make another request. That's what polling is. There we go. Okay. So if we error, we just exit. If we get no value, then we will try again, poll. And if we get a proposal, we'll handle the proposal. Okay. Step 4. Validate proposal using the check methods. And I'm going to copy and paste from a template here, which you can also do for the sake of a tutorial. A post will be in the description. This was a lot. There's at least 4 check methods. Maybe there's 5. We don't have this. We have something called Bitcoin D as our client. All right, let's walk through this. First, we need to make sure this is broadcastable. The proposal they sent us is actually a valid transaction. The way Payjoin works, the sender creates a basic Bitcoin transaction that we could spend that pays us. Sorry, that we could broadcast that pays us. So we check that. And then we make sure it's not spending our inputs. So if the sender was trying to use our own input as an input to the transaction, that we could accidentally sign that. So we want to make sure that's not happening. I mean, being broadcastable prevents that for the most part, but we're being doubly sure. We make sure there are no mixed input scripts. We make sure we haven't seen the inputs before. If we were automated, right now we're not automated, so we can ignore that check. Very important if you're making an interactive payment processor like BTC Pay, but for this purpose we can ignore it. And then we want to make sure that we actually get paid somewhere. So we check the script of the output against the addresses that the receive wallet knows about. And that gives us a Payjoin provisional proposal. Okay. That's this whole part. The implementation details, these functions will depend on the wallet you're using, but for Bitcoin Core, it's pretty straightforward. There are many reference implementations. Let's get on to the actual Payjoin part where we augment the proposal to make a batched transaction. Okay, good. So this is a little tricky, and this is the part of the API that I think is most likely to change. First, we get available inputs from our unspent. We don't need any of these options. Okay. We are going to transform them to be from a vector response from Bitcoin D into a data type that we can actually handle with the Bitcoin, with the Payjoin dev kit. We're going to need to import these available inputs. We don't want to filter them. We want to iterate the map of the inputs. Give ourselves a tuple of I amount and out point txid is I.txid and v out is I v out. Good. And then we collect them into our data type. We're going to have to import all of these. Okay, we have those candidate inputs. Now we're going to use a function that our proposal gives us to select an out point. Try preserving privacy. This makes sure that if we were to add this input to our Payjoin, we wouldn't be creating any heuristic that's identifiable as a Payjoin. So we do candidate inputs yes, and then we actually choose that UTXO based on the selected out point. So let selected UTXO is available inputs. Out point TXID and IV out. So we just match the out point, that's all. I don't know what this is. I didn't want that. Okay, now we have one UTXO that's from the Bitcoin Core software. We're gonna now we have it filtered, but we need to get it in the format that Payjoin DevKit needs, which is a TX out first. And the out point. And now we can actually contribute that input. I'm just using Bec32 addresses because it's the default. I'm gonna make sure these are right. This is an option. This is an option. Okay. All right, we're building. All right, we cargo check pass. Now we're on to the final step. We take this Payjoin we created, we sign it, and we return it to the sender so that they can sign it. The Payjoin DevKit makes this pretty easy. I think it's 2 steps. Payjoin finalize proposal. So this is 2 arguments. The first one is a function to process the PSBT, that's sign it, and the second one is just a minimum fee rate. So first PSBT. We want to make sure this is right. Bitcoin D, wallet process PSBT. We give it the PSBT in hex, none. So do default signing, default sig hash. We do want the BIP32 derivs. And we need to take this output and turn it back into a PSBT type. So that's PSBT from string. Okay, I think that's close as a very long line, of course. And we need that fee rate. Where are we matched here? One more paren. Yes, we need that fee rate now. So that's some Payjoin Bitcoin fee rate. We just want to enforce that. Oops. Oh, I am in the wrong place here. I am in the wrong place. Let's see. We need this, okay. We need this to be a partially signed transaction. Bitcoin D, wallet process PSBT. Things get messy here pretty quick. Wallet process PSBT, paren. Map that result. to a PSBT good. And then we have fee rate min. We don't need what happened. I think it gave me a suggestion here. We got too many. We got the map. Now we need to unwrap that. And close the okay. Okay, good. We need to import this PSBT. We need to import from string. We need to get that fee rate argument. Wrap it in sum. Okay, we got the finalized proposal. We're on the final stretch here. We're gonna just make the request, just like we have multiple times here. Request, context, Payjoin, extract. You can respond to V1 or V2 in V2, so we want to make sure we're using the V2. We're gonna do that actual request now. So let the response equal the request. Content type good, send, await, beautiful. We're gonna process it. I don't think this actually has a response, so just process res. What is it? Need to make sure we handle the error case of finalized proposal. That gives us a Payjoin proposal from which we can extract a request, give that to the HTTP client, process the response, which actually takes a vector, not a slice. There. Okay, so now we've sent the message off. All we want to do is print the TXID so we know what to look for in the mempool. So this is just let Payjoin PSBT was Payjoin PSBT. We need to clone it, and then we want response successful. Launch mempool for successful Payjoin TXID. There we go. Yeah, that's it. We extract the transaction. Whoa, what did I do? Don't press that button. Extract the transaction and get the TXID from that. There we go. All right, so this should work. Let's try it here. Let's try to play this and then send to it from our Payjoin CLI in the other window. So we fetch the key, we got the session started. You can see the session is identified by this key, and we pass the oblivious HTTP key to our counterparty. Got it. So this now we can set this BIP21 using an environment variable for ease. And I think I already have this send string, but just to write it down, you'd run it or run. You could run Payjoin CLI if you had it installed, but I'm running from source. So we're going to run Payjoin CLI with the V2 feature, send to that BIP21 with a fee rate of 1. Let's see if we got amounts that are appropriate. It's pulling the request. Do we get it over here? And the response was successful. So it sent the request here. We shot back a response, and it looks like the TXID came up here. Let's see if we can find it in mempool. I've got Signet over here. And there's our TXID with our Payjoin. That's it. That's really all it takes. Thanks a bunch for sticking along. If you got questions, you can hit me up on Twitter. If you go to bitgould.com, you'll see everything I do, and payjoindevkit.org to get more details about this, payjoin.org for details about Payjoin. Thanks for tuning in.